Do you know where is everybody else? Can you hear me?
Yes.
Okay. So the plan for today is to go through, last time I asked you to implement things, but it didn't work out. This time it will work out, okay? But shall we wait 3 minutes for if more people arrive, and then I will give you the assignment. Okay, so it looks nobody is coming extra. We can start. So who remembers how we define a polynomial ring in Sage? You can unmute yourself and answer, or even better, raise your hand. I'll start. So let's say R in X and Y is a polynomial ring over the rational numbers. Okay. So good. So R is this. And now, let's say that I want to study two curves. Okay, so let's say the first curve f is x squared plus y squared minus 1. That's a polynomial, right? Into variables. How do we plot? I want to plot to see what this is. Any ideas on what the command could be? You have to participate more. So this is the implicit equation. So I want to check if there is an implicit plot, and there is apparently an implicit plot command. So we have to give f the minimum and maximum value for x, the minimum and maximum value for y. Okay. So what we can do is f, and then from -3 to 3, and from -3 to 3. And if I ask to plot, I get the plot. Now, what is the difference? What is the? We have two representations for a curve. One is this, the implicit equation. So we say that the curve is all the points such that this equation is satisfied, is 0. But we have a different way to produce the same curve. What would this be? Okay, so who did the closed captioning again? Can you please tell me who is doing and why? Because I will restart, and if you need this, you have to explain why. Okay, I'm restarting. What is the other way to have to plot a curve? Tuba?
Plotting it in 3-dimension.
No, this is a 2-dimensional curve. I want it in 2 dimensions.
You're asking, we want to draw this one in 2-dimension in a different way, and how? Okay.
So if we just say plot, let's find an example. Must have an example. Yes. So here you give a function and a variable and the range. So let's say h is 1 plus x squared. Then if I say plot h with respect to x from -10 to 10, nothing happens. Why? All right. So I need the variable to be a symbolic variable. So I will have to do, because now let's not mix our variables. Let's call the variable t. I define a variable t. And I get the plot. Okay. So this is a parametric equation. So I have a parameter, and as I run the parameter through the range, it gives me values for both x and y. X is t, y is h of t, right? So this is a different way to plot a curve. Can we plot this curve? What if I gave its, let's call r to be 1 minus t cubed. I'm checking now. Can we give both x and y? No. So now this plots two curves. But we have a parametric plot. So we can give the two coordinates, functions for the two coordinates, and then the variable and the range. So if I say here parametric plot, and then this, what I get is one curve. Let's make it -1, 1 so that we can see stuff. Okay. And now x and y, x is given by h and y is given by r. By the way, if here I do not include 0, I make it 1 to 4, this will probably look better. Not much. It grows too fast. So now why is this a line? Because for every value of the parameter, x and y differ by linear, differ by 2, right? No, sorry, not by 2. But they grow together. So it's a linear function. It's a line. Are we following? How do I make a circle? What are the parametric equations of a circle?
Min max values.
Say again.
Min max x min and y min max and a function.
Yeah, but so what is the function I have to give? I have to give two functions, one for the x's and one for the y's of every point.
Mm-hmm.
And I will have t in the range of 0 to 1, let's say.
Are we allowed to use trigonometric function in that case?
Of course. So what do you do? We are allowed, as you see.
So, in that case, one is sine of t, sine t, and the other one is cosine t.
And until where do I have to go from 0 to?
2 pi.
And we got a circle, right? So you see, we have two ways to write the curve, either in a parametric form, where we say that x is sinus t and y is cosinus t, and then t is the one parameter that gives us every point. By the way, I can make this up to 4 pi. It doesn't change anything, right? In terms of the points it produces. Or we can have the implicit plot, implicit equation, which tells us which points make this 0. Now, which one is more useful? Enis. Burak.
Enis mikrofonun açık.
Aygün. Aygün, you should also write your last name. Can you hear us, Aygün? Gizem?
I don't know, sir.
Haktan? By the way, I'm not asking what you know. I'm asking your opinion on why one would be more useful than the other.
Implicit plot, I think, because we use polynomials.
Okay, yes, that's true. We like polynomials. But in general, for every curve, we have both representations. One is one equation whose solutions are the points, and the other is two equations, two functions, which produce the points according to the parameter. We give one parameter and we get two numbers, which are the two coordinates. This is the parametric, right? So which one would be more useful? Hassan?
I think the second one, sir.
Why?
Because we can give more parameters.
What do you mean? We don't want to give more parameters. I mean, a curve needs one parameter to be drawn. A surface would need two parameters. Seda? Umit? Okay, so first of all, both are useful, but now you have to tell me in which situation each one of them. Is any a game programmer here? None of you works as game programmer? Graphics? Okay. So if you have a scene, right? And so how do you represent? So in games, for example, or in any, you want to represent to show a scene, right? In graphics, scenes are constructed by surfaces, usually 3D scenes, right? So one important thing, the first important thing you need to do is to plot the surface, right? To create points on the surface so that the user sees the surface or the curve in this case, in our case. So which of the two you would prefer in order to plot, to show an object? Yusuf. Yusuf without last name. Put your last name. Ismail?
Parametric form seems more flexible.
To plot, right? But why?
We specify X and Y different each other.
So the point is, if we want to produce all the points, right? So here, in order to find the points, we need to solve this equation. But in order to produce a point here, we just need to plug a value and evaluate, right? So if we want to find the points, then definitely the parametric form is easier. We just said take t from 0 to 2p, to pi, and it produced all the points just by evaluating these two functions. Here, we cannot do the same. We don't know how to find the points. We have to find all the solutions to this equation, right? And that's hard. So if we want to plot, definitely parametric form is better. Then, why do we need the implicit form as well? In graphics, both are needed. Both are heavily used. Any idea? Tuba?
In my opinion, sometimes we need one independent variable to define other independent variable. But in that case, if we don't need just one or to connect other independent variable with one that one variable, then we need implicit form.
So we can always have parametric and implicit. Both forms, every curve has both forms. The difference is that one is one equation and the other is two equations, where in one we have two variables in the first case. In the second case, we have one parameter, because every curve can be described by one parameter. This is the curve is one-dimensional object, right? And this is why we need one parameter. We can always do that. Yeah, so we said that in order to draw, we prefer the second one. What if I give you a point, and I ask you if this point is on the curve? Which in games, for example, you have to check if a car hit a wall, right? You have to check if this point belongs to that curve. How do you do this? If you have the implicit equation, you just plug in the numbers of the point, the coordinates, and you check if it's 0. You evaluate. That's easy. But here, we would have to find the t which produces the point I gave you. And that's hard. Sometimes it's really hard. So for different uses, different representations are better. Then this is why we need to move from one to the other. Okay? So to move from parametric to implicit, this is called implicitization. How can we find the implicit equation, in your opinion? For this, we are given that, and we want to find the implicit equation. How can we find it? Brainstorming, ideas. I want you to talk. You have to talk. I mean, it will be with tools we have already, right? With things we discussed. How do we do this? So we say that x is equal to h of t, right? And y is equal to r of t. Do we agree until here? This is how the parametric equation is defined. And now we want to find something that does not contain t. It contains x and y, right? So the problem here is that we have parametric equations, right? That's sorry, trigonometric equations. But we did do a trick. We said that we'll say that sinus t is a new variable s, and cosinus t is a new variable c. Will this work? And now we have that x is equal to s, which means that actually x minus s is 0. And we have y is equal to r, which means y equals to c. So x minus c is 0. Right? Yes?
But we need a restriction. I mean, s square plus c square is equal 1. We have to add it to parameterize to parameterize this one.
So s square minus plus c square equals 1 means this, right?
Yes.
Okay, so now to define these polynomials, we need a polynomial ring in x, y, c, and s. We define those polynomials, right? And now we'll take the set. I mean, if we multiply by 2 this, nothing changes. If it was 0, it's still 0, right? If we take this plus that, if x and y were equal to s and c respectively, adding them is still 0. 0 plus 0 is 0. So we want all the combinations. And remember that this was the definition of an ideal. So I will take an ideal generated by this set. So it's ideal generated by these polynomials in this ring, in this polynomial ring. This one. Okay. Who needs to be reminded what an ideal is? We all remember? It's good. So we all remember what an ideal is. And what do we do when we have an ideal I? Let's call it I. We want to find a better basis for this ideal. What is a better basis? It's a Gremner basis. So this is a Gremner basis. Wow, apparently this is itself is a Gremner basis, right? So we have a Gremner basis with respect to the lexicographic ordering. By the way, remember, we can say order, and I will give the deg rev lex. Let's see if this will be a different Gremner basis. Actually, it is the same for this ideal. In general, it could be a different one. So we don't need this here. I would say lex, just to make sure it's a lexicographic. So what we need is to get rid of C and S, right? We want something that is only in X and Y. That would be the implicit equation. Let's see. If I say elimination ideal, do I have such a function? I do. So I have to give the variables, and then I can define which algorithm, etc., to use. It doesn't matter. So I will say I want to get rid of C and S. And it didn't work. Why? Okay, because I need to give a list of variables that I want to eliminate. So I will tell you now what the elimination ideal is. But you see that the generator of the elimination ideal, what is it? It's exactly the implicit equation. So that's a way to do implicitization. We take the parametric equations, we compute a Gremner basis of this, and it gives us the implicit equation. This is actually used in practice in graphics. So in computer-aided design, for example. I say graphics, but I mostly mean computer-aided design where curves and surfaces are very useful. Are necessary, not very useful. I mean, in computer-aided design, you use curves and surfaces to design. So, questions? Tuba?
I just want to ask the definition of the ideal. When I look at the definition of the ideal, do we need ideal to get a kind of subset of the field?
Of the ring, of the polynomial ring. It's a subset of the polynomial ring, such that...
Sorry, say a subset of the ring, not field, of course. Because more or less the same, actually, we are, as far as I see from the definition, we are defining a new kind of mathematical notion, just taking a bunch of elements from the ring.
Yes, we take every element of the ring that is a linear combination of the generators. So every polynomial that can be written as a combination of these polynomials is in this set. And one of those polynomials is this. This polynomial, we can write it as a combination of those. Shall we check how? Yeah, it's not so hard to see how, right? Because you say that S is equal to X, so you reduce this. Okay, let's say that F1 is this, F2 is that, and F3 is that one. So now, if I say F1 reduce by F2,
F2 and F3.
It must be F3. F3 reduce, no, sorry, F1 reduce F2 and 3.
okay, much better. So you have to change the order maybe. Yes, you see? So now, since the variable C is larger than the variable X, so S is larger than X, this polynomial is S minus X. So when I start doing the division, I will take S, which is the leading term, divides S squared, and the remainder is S. Sorry, the quotient is S. So I will gradually exchange the S's with the X's when I do the division. And the result will be this. And now if I reduce this by F1, this will change by not F1, F3, sorry. This will change the Y's, the C's with a Y, right? So now you see that actually this polynomial belongs to the ideal because it is a linear combination of those polynomials. Questions? Okay, so this is actually a very important thing in computer-aided design, the change of representation. And this is one of the important applications of grammar basis, as you see. Now, do we have another way to do the elimination? Okay, so let's have a break. And when we return, we will break into teams and we will try to implement a function that does implicitization, okay?
Okay.
Let's have a break. We're back. rooms, but also I see a lot of people not being here. I will restart the meeting to check if I can enable breakout rooms.
Okay.
I opened the breakout rooms. You can split as you wish in groups. Okay, sorry. Before you join sorry, don't join yet. I'm sorry. I will first. Can you see CoCalc?
Hocam, can you wait for a while because some of our friends try to get in.
Okay. Do not enter the breakout rooms yet, by the way. As I said. Are we ready?
Hocam, Gizem is still trying to do it. I think she has a problem. Hocam, Gizem can join
Okay.
the
We will start anyway.
class. Okay.
Hopefully she will join. So the point is, we saw an example. Now you should write a function. You should split in 4 rooms. You're 8 people, 9 people. You should split in rooms, in groups of 2 or 3 people, to create a function that takes. So what will be the input? It will be 2 functions f and z. So let's make them polynomial for now. So not trigonometric functions. It will be polynomials. The input is this. So I want the function implicitized that takes f and z, and they are in a polynomial ring in a univariate polynomial ring. Okay, these are the parametric curve is y of t is x of t So I have a parametric curve. Every point is given like this. The first coordinate of the point is f of x, and the second is g of x, for x in some range. Okay. F and g are univariate polynomials, and I want to find the implicit equation of this parametric curve. Are there questions? Is the question clear? Okay. If you say nothing, I assume it's clear. So you can go to the breakout rooms and start working on it, and I will be coming from room to room. Okay. I think you can. Yes.
I couldn't find break You say breakout room. How can we join the breakout room?
There are 4 rooms.
In Teams? Did you publish in Teams?
No, it is in Zoom. There must be a breakout in more or somewhere. There is a button to join a breakout.
Yeah, I saw in here. Yeah. Sorry.
Okay, so now
we
you
are gonna choose the room randomly, or
you can split as you wish.
Okay. Thank you.
Şimdi bir şey mi yapmamız lazım?
Okay, so there were in the end there were 2 groups. Someone from the second group, well, you don't know which is first and second. I think Ismail was sharing the screen, right? Can you share?
I was sharing my screen.
Mm-hmm. And someone else from the team should tell us what they did.
Can you see?
Yes. Who else was in your team?
Ibrahim, and there was
Ibrahim, do you want to explain what's happening? Okay. Ibrahim cannot talk, I think. Why?
I don't remember the other guy. I'm sorry.
Okay. So anyway, tell us what the function is doing.
It first takes a variable t from f. That's the parameter variable. In this case, it's a. It creates a ring with x, y, and this variable. Then I create an ideal, just like we showed, and
So
eliminate
like x equals f, y equals z. But
yes,
saying that you have to cast f and z in the new ring, because otherwise they were univariate polynomials, but now we want them to be part of the multivariate ring with x, y, and the parameter, right?
yes. Why my voice? I'm sorry. Then we what is good? And then we eliminate the ideal, and we take the generator of it, and it gives the implicit form. Then we can check if they are equal by plotting them. And this is the plot of the implicit form, and this is the plot of the parametric form.
Okay. Questions? Gizem, Aktan, Tuba, Kanjan.
Can I ask question?
Yes.
Is it detecting which type of input standing from line 14? For example, if we choose T, is detecting from there, I think.
Exactly.
Yes.
So you can change. So there you ask what are the variables that participate in F.
Yeah,
Right?
our group can't handle it. If we know this, we could done it too.
Yeah, but the main problem in your group was that you didn't define correctly the polynomials. You didn't say x minus f, y minus g. You were
Yeah.
also adding some f and g and x there separately.
Yeah,
And this is
that's
why it
not
didn't
necessary.
work. Right?
Sir, also there's another way to detect which variable used for example, A, T, C.
Uh-huh.
Is it,
How?
is it the only way to detect
No,
this?
no, it's not. What is the other way?
I don't know.
So every polynomial belongs to, every object in Sage belongs to a parent, right? So Ismail, can you write f dot parent? So this tells you that it belongs to this polynomial ring. And every polynomial ring has generators, which are the variables, right? Can you write dot gens after parent? So, and this will give you the list of variables of the polynomial ring. If it had more variables, it will give you more in the list.
Yeah.
And that's true for any object, because every object has a parent in Sage. That's a difference. So what Sage does is introduce a type system above Python. So it uses Python, but with a type system. And also this is why you can cast things, like in line 16, right, where we say RF, we say, okay, F, the parent of F used to be the univariate ring, but now we embed F in the multivariate ring. And we can do this because we still have a variable called A. So it knows how to do it, right?
We are casting to X and Y.
We're casting F from being of type univariate polynomial in A to being a multivariate polynomial in X, Y, A. The fact that it doesn't contain X and Y doesn't matter, right? We just see it as a polynomial in 3 variables that only contain 1. But when you say R of F, this means that now, so the result of this call is a polynomial in 3 variables, although it contains only 1. Is it clear?
Yes.
Okay. That was simplification. And how you write a function. So I mean, you have to get used a bit on how you write a function in Sage. I mean, it's Python, fine, but you know how to use the types properly. So remember what we did last week? I want you to write functions for next week, to write functions that are doing like properly, not assuming what variable the user should use, but computing it, finding out for the things we did last week, like Buchberger's algorithm, etc. I think we did that anyway. And I want you to run some experiments to see your implementation of Gremner basis through Buchberger's algorithm and Sage's implementation. What is the performance difference of the two? And also run some examples with different ordering. So you see here in line 15, we give the order. So instead of this, you could give deg revlex, for example. So if you see the documentation, it gives some predefined orders. Check those and see if there is a difference in the performance, how long it takes to compute a Gremner basis. Not a very small one. For very small ones, there will be no difference essentially. But if it takes like 10 minutes or even 1 minute, there might be a difference between 1 minute and 10 minutes, depending on the order. Try to find such examples, okay? I hope it's okay. So next week, we will do theory in the class, okay? And then we will continue again with implementing the theory we will see. Are there questions for today? Okay,
sir,
then
thank you.
see you next week.
Next week, sir.
Bye.